Okay, good morning again. We talked about how we're gonna do the final exam on June 2nd, and I'll upload the extra session we took on last Saturday today, inshallah. And the exam is you're gonna have a link under exams, quizzes and exams over here. You just follow it and follow the instructions. And let's move to our new topic, last chapter, that is official. You requested to, it's part of the exam. Chapter 11, we covered it, the A to D. Chapter 10, the serial communication, I'm going to cover it in an additional extra session later. Chapter 8 is about human and physical interfaces. And by the way, I think this is going to be a fun chapter. Not much stuff here. So chapter 8. And today is May 12th. Human physical interface. It talks about this microcontroller we're dealing with. What we have been covering in the past, since the beginning of the semester. How does the internal architecture look like? So how are the ports interfaced with the internal registers and ports? That was chapter 3. Then chapter 4 and 5, we learned the language of this microcontroller. Then chapter 6, we learned about interrupts versus normal sequential execution of programs. And then we talked about external interrupts, overflow interrupts, port B change interrupts. Chapter 6. Then we moved to chapter 7, where we expanded. We moved from a small 18-pin microcontroller to a larger 40-pin microcontroller. And we saw the differences, how the program memory is larger and has pages, and how is the data memory larger and has banks, and what are the extra ports and extra interrupts that in this larger microcontroller. In the extra session that we had last Saturday, we covered one peripheral that exists in the larger system, which is the analog to digital conversion, how to interface devices that provide analog voltage and be able to convert voltage into a number that is meaningful and give a value of a physical entity you want to measure, like temperature or humidity or whatever. Then this is chapter 8. طبعا راح يظل chapter 10 with the serial communication, how the controller is going to be able to communicate with other devices, like other computers, other controllers, etc. Chapter 8 is about how to interface with the human, okay? With the human. So in the sensor, we're going to do the two-way human interfaces. We're going to see how the controller is going to be able to interface with devices that will be able to sense the physical world around it. Sensors. And you did a mini research about sensors. So by now you know what are sensors, what they are. A sensor is something that senses the real world around you, like what is the temperature, is there a movement or a motion, what's the humidity, what's the speed of something, so on. And the sensors, usually they give their value, when the sensor either output a digital signal, digital voltage, high or low, so you read it on a digital pin, I/O pin, or give an analog pin, analog voltage, and you need an analog to digital converter in this case, the analog voltage into a 10-bit digital number. And they can give their readings as serially, bit after a bit in a serial fashion. This is the thing we're going to talk about in chapter 10. So sensors. And the other part is actuators. So how will the microcontroller be able to open a door, to open a window, to turn off lights? And so we're going to talk about actuators and interfaces with the actuators. And the last thing is the human machine interfaces, visual interfaces that accept commands or display the status of something to the human. So among these, مثلا, push buttons, right? We dealt with push buttons, keypads like here, any example, and a graphical display, 7-segment display, push buttons, keypads, LCD, right? So many different ways to interact with the device. So we're going to talk about, in this chapter, about some of the main famous devices. We're going to talk about 7-segment displays, how they work, how do we interface them with the microcontroller. This is the microcontroller. Keypads, we're going to talk about keypads. These keypads are input devices, 7 segments are output devices. And these are LCDs. I think in Jawad did the demo in the simulator how to use LCDs, so I'm not going to cover it here. And so on. In the past, we talked about simple push buttons. We talked about simple LEDs, right? So these are larger versions. A keypad is a larger version. Push buttons, you deal with it differently. 7 segments are LEDs. But we'll see how we deal with them. We start with keypad. Why would we need a keypad? Imagine you have how many push buttons here? 12, right? If you have 12 push buttons, that you want to interface with a microcontroller, a 16F877A controller, 12 push buttons will need 12 ports, right? 1, 2, 3, 4, 5, 6, 7, 8. مثلا port B. Then 4 bits of port C. Imagine 12 pins out of how many, what's left? Let's say port A and E are analog. So what left? You consumed half of your digital ports. What's left is port D and 4 bits of port C. For push buttons only, you consumed half of the available digital buttons. There should be an easier way. If you need more, what do? You need more ports. So one smart solution is to use a keypad structure. So the push button, you connect it in this manner into rows, okay, rows, and columns. 3 columns, 4 rows. 1, 2, 3, 4 rows, and 1, 2, 3 columns. In this case, how many pins will you need? 7, right? 7. You need for each row 1 parallel pin, and for each column 1 parallel pin. So 3 columns, 4 rows, 7. You need 7 pins. Versus 12. If I need to connect each, right? So 7 versus 12. If you connect them normally, just as normal push buttons. So how do I connect something like this? A simple way, and you're going to do this in the lab. So I'm not going to really go do a demo, but I'm going to give you the idea. So if you have your microcontroller, you take these pins, the 4, 1, 2, 3, 4, to any port. What port? Let's say port B. Port B, 1, 2, 3, 4. Port B, okay? And to make the code easier, take these to port C. ماشي 1 2 or يعني هذول lower 4 bit to port B and these the higher 4 bit to port B, whatever, parallel port. So to be able to figure when somebody pushes this button, for example, number 5. So the microcontroller, how will the microcontroller know that button 5 is the one that is pressed? First of all, when you interface and today we have a keypad ready, right, with all the buttons, and you don't have to build it. But you take these 7 lines coming out of it. First thing, you pull each one of these lines to high through a pull-up resistor. يعني هذا this line is pulled up to the voltage source. This line is pulled up to the voltage source, and so on. All of them. Then, يعني here we're assuming that these are connected to a single port. Let's say port B, starting port B1, this one, and 0 is floating. The 7th is port B7, which is this one. These are the 3 columns. These are the 4 rows. 4 rows, 3 columns. Then, okay. So you set the column bits as output. You set the raw bits as input. Set the column bits to 0. You write zeros on them, and then you read the raws. And I did it the opposite way, صح? Which is fine, completely fine. You read the raws. When you read the raws, you have 4 raws. You will get a number. 0 1 1 1 1 or 0 1 1 1 4. You get 1 0 in these 4 bits, which defines which raw is, and in this case, the first raw, the second raw, here, third raw, fourth raw. Then you do the opposite. Set the column bits as input, set the raw bits as output, and write zeros on the raws and read the columns. So you figure what column is pressed. And the other, when you finish this cycle, you can flip, make these as input, and make these as output, and write zeros on the output and read inputs. تمام? You'll get these 3 bits. Concatenate them, you'll get a number. Then if condition or lookup table, if what you read in the 2 cycles is this, then the key that was pushed is 1. If what you read is this, then 2, etc. Okay. How do we translate? This is a software design, جماعة. The electrical design is to say that these are connected to port B, connected to port B1 to 4. These are connected to port B5 to 6. Okay. This software design. To convert it to software, sometimes you may be asked to do that, but set column bits as output. Bits were the column bits, these ones, the 3 were port B1, 2, and 3, right? So what you do is raw bits as input, raw bits هذولا 4, 5, 6, 7. Then what you need to set port B is puts are 0, 0, 0. والأول you don't care about, make it 0, 1, 1, 1, 1. Then PRISB, you write in it 0xF0, right? there's these. Then here, set columns bits to 0. So, well, if you write to port B zeros, you're not going to be able to write on the input. So you can just say port B equals 0. Say if, يعني read port B, if port B equals, you're going to read the RAS, right? Well, also store it. Don't say if, for later. Say port B, say store it in somewhere it's called rows. يعني عم نعرف integer rows, store it. Then set columns to as input, like هذول يعني, right? So for these lines, so you say TRIB equals 0x 0f, then port B, write 0 in it, then in columns store port B, right? Then خلينا نيجي هون, you say reading or button, whatever بدك إياه, or reading equals what? Columns or buttons, right? So you're gonna get what you read from here and what you read from here. You're gonna concatenate the rows and buttons. Then if reading was equal to this, أنا بطلت أشوف من let me just remove the يعني let's assume it was 0 1 1 1 0 1 1 1 or 0 يعني or equal 0 1 1 1 0 1 1 0, then button is equal to 1. Else, if the reading was equal to this, then the button was 2. I can in the code. Okay. Okay, no questions. Easy. Move. 7 segment displays. Did you deal with 7 segment displays before? Digital logic, somewhere else?
Yes, دكتور بالمايكرو.
Yes.
Okay, so يعني you're so familiar. So 7 segment displays are LEDs, right? LEDs. But they are sorted in a way to make this shape, the shape of a number, right? The LEDs have an anode or a cathode. If all anodes are connected together, then we call this a common anode, right? Common anode. If all cathodes are connected together, then we call it a common cathode, right? A 7 segment display, let me see if I have one here. I don't know. Like a 7 segment display, is it in the next slide here? Yes. Looks like here. 7 segment display. Each LED in it is called a segment. That's why it's a 7 segment. And usually you have a decimal point here. So the segments have names. This is A, this is B, C, D, E, F, G, and the dot is H. And these are A, B, C, D, E, F, G, H. A, C, D, E, F, G, H. Now, if I want to see the number 0, يعني turn LEDs to see a 0, I need to turn A on, صح? B on, C on, E on, F on, G off, right? So 0. And H, I don't want the semaphore. Is this correct? So we write, oh man. So we write a 3F here, right? Assuming that the 7 segment display I have is, so A, B, C, D, E, and this is the pin out of it, F, G, H. So we have usually the pins are like this, A, B, this is the common, C, so A, B, this is C, D, E, this is the common, G, H. وقت is gonna راح يخلص. هلا هذول you take them together. These are the common. The common anode, you take these to high to the voltage source, right? And to be able to turn on a segment right is 0. So العكس راح يكون 0 0 0 0 0 0 1 1 to write a 0. But if you this 7 segment was a common cathode, you take this to ground, right? To ground, and to turn on a segment you write a 1 زي ما عملنا هون. Okay. Okay. Now, how many pins do I need to interface a 7 segment display to my microcontroller? 1 2 3 4 1 2 3 4. I need a full port, صح? Port B. So port B, 8 pins. 8 pins to interface a single 7 segment display. And guys, if you have a class, you can go, and I'm gonna keep the recording and you watch it. I'm not gonna stop in the middle. Okay. طيب, what if I have 2 7 segment displays? What if I have 4 7? Imagine if I have 4, I run out of LED of parallel ports. If each one needs 8 ports, this one needs 8, this one needs 8, هاي 16, كمان 2, هاي 32. We ran port B, C, D, and A, and make them together. We use all our ports for 7 segment displays. So this way of directly connecting the 7 segment display to a microcontroller, each pin on each segment treated as a separate LED and connected to the microcontroller is a waste of resources. So what do? We may use this common. So let's talk about if we're using a common cathode 7 segment display. This has a common. This is a common. This one also has a common cathode. If this is a common cathode and I connect this to high, if you write a 1 here, will the LCD A, B, C, will this turn on? If you have an LED, you have a 1 here and a 1 here, will it turn on? No. Answer is no. If you have the common, it has to be connected to ground, right? So when you write a 1 and this is connected to ground, the LED will turn on. But if this is 1 and what you write here, you're not going to be able to turn on the LED. So we can use the common cathode here as an enable. And this one as an enable. And take them with logic to 2 pins here. And here to port to 2 pins. Port 0, C, 1. And all these A, B, C, D, E, F, G, H. A is connected to A in here and A here. B is connected to B here and B here. Go on for G, H is here and H is here. So if I write 3F on port B, and both port C0 and C1 are 0, 0, I will see what? 0 here and 0 here. But if I write on port C 0, 1 instead of 0, 0, this will be enabled, this will be disabled. So I'll see the 0 here, and this will be off. No LEDs will be on. If I want to see the 0 here, I make this 1, 0. So I enable this LCD. Tamam? If I want it to show on both, I write 0, 0. I turn off them, all of them, I write 1, 1. Use the as an enable. What if I have four 7-segment displays? And for 2 displays, using normal, if I connect every segment to a port, we needed 8 pins for each segment, so 16 pins. Now, way we needed 8 plus 2, so 10. So how do I display a number of 2 digits on these? Like any 20, 25. How do I display a 25, a 2 here, and a 5 here? And you see them, you want to see them solid in front of you as a human. What we do is write a 5 and enable this one for 2 milliseconds. Then we write a 2 on port B and enable this one for 2 milliseconds and disable this one, turn this off. So we will be having a 5 here for 2 milliseconds, then turning this off and this on for 2 milliseconds and writing a 2 on it. So we'll have a 2, 5, 2, 5, 2, 5, 2, 5, switching really fast, where you not recognize this switching. So you will see a 25. We call this time multiplexing. Call this time multiplexing. If we have 4 7-segment displays, the same thing. Instead of controlling them with port C0 and 1, we have C0, 1, 2, and 3. But we still saved a lot of ports. Instead of using 8 times 4 ports, we used 8 ports plus 4. Okay. This shows the multiplexing, how this is in our. Sometimes, and these are, it's a common, so I had a common cathode. So imagine all the LEDs are on. You have, and you write a 0 on the port C, مثلا, port C4, okay? And you don't want to hurt your controller. You cannot turn all these on. You cannot sync a current above a certain threshold. So you cannot connect them directly to 0. So you use a transistor here and take them to ground. And if you want to enable this one, you write a 1 on the port C4, for example. And the channel will connect this to ground. Then these will be enabled. Okay. If you want this, you write a 1 here. Now on our microcontroller, on our board, we have 4 7-segment displays. We used them in that last session when we connected the analog to digital conversion voltage, and we showed it on the 7-segment displays. These 4, the display, the pins A, B, C, D, E, F are connected to port D. These pins are connected to port D. طيب. But it doesn't matter if I ask you in an exam or to design a system and connect them to port C. You can do that. But in this particular case, on this board, they are connected to port D. The common cathodes are connected through these interfaces, transistors, and these are enabled, the channels are enabled through port A. Port A0 for this 7 segment, port A0, this one for port A1, port A2, and port A3. You can pull them to high through this dip switch, or you can just make these pins as digital and write 1, 0, 0, 0. In this case, whatever you write on port B is going to show only on this 7 segment display. If you write 1, 1, 0, 0, you're going to see on these 7 segment displays. If you write 0, 0, 1, 0, this 7 segment display is the only one that is going to show the 3F you write here and see. That's it. So I'm gonna, this is a demo. This is a demo. I'm gonna do real quick that displays the numbers from 9, counting from 0 to 9. So I developed a 7 segment map. A 3F is a 0. A 06, if you track it, a 06 is all bits. A 06 is this. يعني 06, 0, 6 is 0, 1, 1, 0. So the only LEDs that are on is this one and this one. So what will you see? You will see a 1, صح? You will see a 1, and so on. So we made all the calculations. To see a 2, how do I see a 2? I need to turn these LEDs on, right? So A, B, C is off, D, E, F is off, and G, right? So you write A, B, C, D, E, F, G, A, B, C, D, E, F, G. So A is 1, B is 1, C is 0, D is 1, E is 1, F is 0, and G is 1. So we write a what? 5, and this is a B, 0x, 5B. So if we go here, a 2 is 5B. And so on. Then in the interrupt that we wrote in previous example, that gets us here into this, if the ticks are 33 every 1 second, if I configure the interrupt to happen every 32 milliseconds times 33, then we're here inside here for every 1 millisecond. I have a counter I increment it I plus 1 plus 1 plus 1 every second. So I have a counter that increments every second. When it reaches 10, it goes back to 0. Okay, in the main loop, I just configured port D as output because it's connected to the 7 segment. The option register to control the timer to make it overflow every 32 milliseconds. Enable the interrupts, and in the while loop, I just display my 7 segment, this one of I that I am incrementing on port D. Port D is connected to the 7 segment display. I is a number, so when I pass a 0, I'm gonna return my 7 seg of 0, the 3F. So I'll show a 3F on port D. If this is 1, I'll show a 06 on port D, and so on. If we take this code, execute it, and we're done. And I'm done with the class. I'm just gonna rest is to show 2 demos about using the 7 segment displays. Okay. What did I do? So I'm gonna start a new project. And call it class demo 13. 13. And here is a single 7 segment display. Okay. This is the code I just explained. I want to build it and run it on my microcontroller. And here, if you see, I did not touch anything about in port A. I did not enable port A. So I didn't do anything for port A. So I'm going to physically go pull the bit, the common cathode, to ground by making port A high, and by enforcing it. ماشي. So I'm gonna stop sharing and go share my other camera so you guys see the 7 segment. What do I do? Yeah, turn on my other camera. You see my board, right? And the 7 segments are here. See them? They're all off. Why? Because I did not take the common cathode of any of them. Did you see in my code anything I did with port A? No. So, but we know that the common cathode is connected to ground if you write a 1 to port A0 for this one, for port A1 for this one. So if I want to display the numbers here, but you can see, by the way, that port D is changing here. High port D. This is port D. And our program is changing. Every second, the number is changing. But we're not seeing it in a 7-segment display format. So I'm going to go pull port A0 to high. Here you go. See the numbers? Yeah, see them now? So, okay, it adjusts by itself. I hope you see it, but I need a confirmation. You see the numbers?
Yes, واضحة.
واضحة? Okay. Okay, so it's counting from 0, 1, 2 to 9, then it goes back to 0. But I was able to show them here by physically pulling port A to high. So if I want to show, if I pull port A0 and A1 to high, and let me do this, I'll see the same reading on 2 7 segments. See it? You see them on the 2 7 segments? Yeah. If I do A3, I'll see them on the 3. 4, I'll see them on the 4. Okay? And I did this physically. I pulled, I took the line and connected it to the voltage source. I didn't do it in software. We can do it in software. So let me go back. What did I do? Let me go back and do the second demo and finish. The second demo is for 2 digits. Okay? Let me take it and I'll talk about it over there in the code for 2 digits. And here we're doing time multiplexing. Here. So I'm gonna start a new project, close this project, create a new project. Okay, and here's the code. I'll paste it. See what I did here, guys. As I have the 7-segment map here. I have an interrupt that overflows every 32 milliseconds, a timer 0 interrupt. every time I increment a tick, something, an unsigned character. When the tick is 33, then 1 second has elapsed. So every second I increment I. This time I want to make I 2 digits, and it counts from 0 to 99. From 0 to 99. Okay, to count from 00 to 99. When I is equal to 100, I reset it back to 0. Tamam? Then 99, as we said, to do time multiplexing, I need to split it, any number, any 2-digit number. So let's say I have a 57. I equals 57. How do I display it? And 7-segment displays. Display 1 and display 2. I need to display the 7 over here, right? And display the 5 over here. So, but we know that these are all connected to port D. So what I want to do is to enable this for a short amount of time and write to port D a 7. It will go only here because this is disabled. Then I want to make this one and this 0, sorry, this 0 and this 1, yani enable this one and disable this one after a very short amount of time, and write a 5 to port D. So the 5 will show here, and this will be off. This if I'm doing this 4 milliseconds on, and then this one 4 milliseconds on, and that one is off, you're going to see a 7 and 5 next to each other while they're not really. Okay? So this is what I'm going to do. So to be able, first, I need to split it into 2 digits, to a 5 and a 7. How do I do that? I divide. I want a remainder and a quotient. So if I divide I by 10, you get what? The quotient, right? You'll get this part. وهذا لأنه we're doing integer math, it's gonna be 0.7 صح? So it will be lost. So Q will be في هاي الحالة 5. The remainder, you take the remainder of multiplying dividing I by 10. صح? The remainder of dividing 57 by 10 is 7, right? In this case, you got the 7 in R. Then I display on port D R and enable this one. Then when I enable this one, I display Q. Real quick, 4 millisecond, 4 millisecond. Is this clear so far? Okay. No news, good news. So what I'm doing here, I'm just taking the quotient QQ by dividing I by 10 and taking the remainder by taking the remainder of dividing I by 10. Then I reset the tick to 0 because the 1 second elapsed. I need to get here after 1 second. So after 1 tick is 33 one more time. Then I reset the flag, the interrupt. Tamam? So we split the number into the digits here inside the interrupt. And we increment the number inside the interrupt. In the main loop, first I did the initializations here. I set these out because it's the one connected to the 7-segment display. Initialize it to 0. Now, to enable the first 7-segment display and second segment display, I need to use port A. Port A, I said it last time, is default by digital, is analog by default. Port A is analog by default. To make it digital, there is a register called ADCON1. I write a 06 into it. How and why explains an extra class session, and you will find it uploaded today, inshallah. But if you want to deal with this, you can. So writing 06 to ADCON1 will make port A become digital. Then, in this case, I define port A directly because I'm going to write on port A. Option register is the timing for the overflow interrupt. Clear time 0, start from 0. Enable interrupt the timer 0 locally and globally. Initiate all the things that I defined up there to 0. Then this is the important part. I'm saying if timer 0 is a value, يعني first 4 milliseconds, for example, I'll explain this really quick. Enable the second digit and display the quotient, else enable the first bit and display the remainder. So I'm doing the switching here. But how am I doing this? Timer 0 يا جماعة. Timer 0, we set in the register to increment every how much time? Let's go do the math. Timer 0. Timer 0 is an 8-bit timer, right? That increments, well, it is 8-bit, 1, 2, 3, 4, 1, 2, 3, 4. That counts from 0 to 255, then goes back to 0, right? We made it overflow we used the oscillator, right? Over 4, which is 2 megahertz clock. Then we use the scaler 256, right? So time increment is 1 over 2 megahertz, which is 0.5 microseconds, right? And we did math long time ago, times 256, right? Prescaler. So every 128 microseconds. Time increment. تمام؟ طيب. Please concentrate here. Time to increment is 28. Time to overflow equals 128 اللي هو time to increment per seconds اللي time to increment times the number of counts, right? 256 count, which is it was the 32 point something milliseconds, right? Right. What I care about here is time to, the overflow, we did it and it overflows and we did the 1 second increment. Now this is a different purpose. We're using the same time for another purpose now. So this timer is gonna move from 0, 0, 0, 0, 0, 0, 0 to 1, 0, 0, 0, 0, 0 after how much time? 128 microseconds. Then it's gonna move 0, 0, 0, 0, 0, 0, 1, 0 يعني 2 صح 0, 1, 2 after 128 microseconds. Then it's gonna become 0, 0, 0, 0, 0, 0, 1, 1 after 128 microsecond. Then let me just concentrate on these 4 bits are gonna stay 0 for a while. It's going to become 0, 0, 0, 0, 1, 0, 1, 0, 1, 1, 0. So if this number is incrementing every 128 microseconds, this means this bit 0 is going to stay, if this is time, is going to be 0 for 128 microsecond, 1 for 128 microsecond, 0 for 128 microsecond, 1 for 128 microseconds. Right? So 128 microseconds, 128 microseconds, 128 microseconds. Like what? So this one, you're 0 for 128 microseconds, and 1 for 128 microseconds. You're 1, right? What about this? Double the times, because you need to flip 2 times for this one to change. So 2 zeros to 1s, 2 zeros to 1s, right? So this the double. Instead of if staying 128 microseconds, it's going to stay for 256 microseconds. This one, 4 times, صح? 4 zeros, 4 ones, صح? So this is 512 microseconds. This one, 1024 microseconds. يعني قديش؟ 1 millisecond. This one, 2 milliseconds. This one, 4 milliseconds. This one, 8 milliseconds. This one, 16 milliseconds. تمام? What I'm doing in my program, if I want to turn on the first 7-segment display for 2 milliseconds, and then turn on the other 7-segment display for 2 milliseconds, I want to check for this bit. If it's 0, I enable the first 7-segment display. If it's 1, I enable the second 7-segment display. So in this case, I will enable the first 7-segment display for 2 milliseconds and the other one for 2 milliseconds. But if I need a little longer, يعني 4 milliseconds, then I'll check for this bit. Clear? Are you guys still here?
Yes.
Yes, doctor.
So what I'm doing here, يعني, let's do it. How much time do you want to do it? Let's start with 2 milliseconds. 2 milliseconds. 2 milliseconds is 0, 1, 2, 3. يعني هاي 2 milliseconds. This is 2 milliseconds. So this is bit what? I want to mask everything else and keep this one. I want to check for this bit if it's 0 or 1. تمام? This bit ترتيبه 0, 1, 0, 0. يعني if I want to mask everything, let me write in blue. I write 0, 0, 0, 1, 0, 0, 0, 0. If this is true, then this is 1. This bit is 1. If false, then this bit is 0. It will be changing 1, 0 every 2 milliseconds. Okay? So I want to mask, I'll AND this port, timer 0, sorry, with what? With 0x, 10 hex. So let me go in the code I have here. In the code I have here, I choose longer time, but it's okay. Okay, so 10. If this is true, then that bit that changes, bit number 5, if we count from 0, 1, 2, 3, 4, 5, will switch every 2 milliseconds, will be 1 for 2 milliseconds, then it will become 0. So this condition is not true anymore. It will go to the false. Okay? If it's true, I'm going to enable the display, the second one, because port A, I made it 2. And here, for 2 milliseconds, I have one 7-segment display, and I have a second 7-segment display. And each of one of them has an enable, صح? The enable in this case is what? The common cathode. And they are connected through port A to ground. Port A 0, port A 1. So I want to display on this one, I write A0, A1, I write 0, 1, right? If I want to display on this one, I write 1, 0. If I want to write on this one, sorry, I write 1, 0. If I want to write on the other one, I write 0, 1. I write 1, 0. So this will be display on display 1. And this will enable display 2. But if I want to enable display 3, and display 4, I have port A2 and port A3. To enable display 3 or 3, I write this. To enable display 4, I write 1, 0, 0, 0. This is what I'm doing in the code. I wrote 2. 2 is what? يعني 0 1 0. So I'm enabling the second 7 display to display the tens اللي هو الquotient العشرات on port D. Then after 2 milliseconds, this is not going to be true anymore. I'm going to go to the else. In this case, I enabled the first 7 segment display to enable to display the first part of the number, the remainder, الأحاد, on port D. And that's it. Let me build and program. And in this case, في مشاكل هون بالكود. Invalid expression. What's invalid? What's invalid? The tick is probably small letter, صح? This one is small. هاي semicolon كمان غلط. No. Programming. طيب, done programming. Let me stop sharing. Let me stop sharing. How do I stop sharing? Anyway, guys, it's just about the demo. Let me turn on the other camera. You see the numbers? Let me reset. 0 0 1 2 3. Is good. You see the numbers? Well, I'm clear. Well, I don't know.
Yes, yes.
Now 9, but then 10, 11, 12. It's gonna keep jump. You see them solid, صح? You see them like if we are يعني in parallel. While
yes,
really
بيطلع مع بعض.
time multiplexing, you see them كأنهم, yes, both are connected. While we know we wrote our program, we only writing on port D.
Yes.
Right? But we're enabling one and disabling one in really fast time, in 2 milliseconds. This is called time multiplexing. For time multiplexing 7 segment displays. Okay. And I believe you're going to do this in the lab as well. So that's it for today. The second part, we'll finish it on Thursday of chapter 5 or chapter 8, which is about sensors and H bridges. And probably we're going to take more time like this, and whoever has to leave can watch the recording. Yani, we'll have to pay the price. If you want a break next week, then we have to take this extra 30 minutes. You can watch it and ask about it. Okay, thank you very much. If you want to stay for questions, you're welcome. See you Thursday.